Right, hello and welcome back to Rate of Reaction. So your keywords today are collision, particle, energy, activation and speed. Your little do now activity now is to think about how you could speed up this reaction, okay? So you're making some pasta. How could you speed it up? If you're using your class notebook, then you already should have your date, title, keywords and your learning objective. If you don't, then you need to add them in on your bit of paper. Describe collision theory and evaluate how to measure rate. So we're going to describe something called collision theory. So first off, I want you to pause the screen and think about how you could maybe speed up this rate of reaction. Okay, so number one, we could break the pasta. Okay, and that would also be known as something to do with surface area. Number two, we could add salt, okay, and that might be known as a catalyst in chemistry. We could change the volume of water. Okay, so if there's less water, it might cook quicker, okay. Maybe the type of pasta. So I'm sure you've got loads in yours, but make sure you add them in. Okay, so we're going to look at what needs to happen for a chemical reaction to take place, okay? And this is also known as collision theory. Okay, so for a chemical reaction to occur, the reactant particles must collide, okay? So if we're thinking about writing or drawing out a chemical reaction, okay, and we've previously learnt about how we have our reactants on this side, and how we have our products on this side. Okay, so for us to make a new product, okay, can you notice how you've got the same type? Okay, so nothing new has been made. You've got this one and this one, okay, and then this, you've still got the same type, okay, and we'd say they're the same type of atoms. So for a chemical reaction to occur, these reactant, so there are reactant particles, need to collide, okay? In chemistry, we don't use the word bump in, we use the word collide, okay? They must collide with enough energy, okay? So colliding particles must collide with enough energy to be successful or effective in producing a reaction, okay? So particles are constantly colliding. Okay, but it's only when they collide with enough energy does a reaction take place, okay? And this minimum amount of energy is known as activation energy, okay? That's an important definition to write down, okay? And what happens is that the bonds are broken when they collide with enough energy and new bonds are formed. And then finally, the rate of reaction depends on the rate of successful collisions between the reactant particle. The more successful collisions they are, the faster the rate of reaction, okay? And a new product is formed, okay? New product is formed with new bonds, okay? So what you need to be thinking about now is how you're going to note that down, whether you're going to draw a diagram or just fill in the bits of paper. But on your class notebook, that needs to be filled in with what's happening in each diagram. Okay, and then the next thing we need to do is you guys need to press pause and fill in the blanks on this little review. Okay, for a reaction particle to occur, two reactant particles must collide to form a new product. For this reaction to occur, the particles must collide with enough energy. This is called activation energy, okay? The rate of reaction depends on the rate of successful collisions. The more successful collisions there are, the faster the rate of reaction, okay? Remember, particles are always colliding, okay? They're always colliding, but it's only when they collide with enough energy does a reaction take place, okay? So they're always colliding. It's only when they collide with enough energy does a reaction take place. Okay, so another thing that you need to know about is how we measure rate, okay? So the rate of reaction can be found by measuring the amount of product formed in a certain time, okay? And these are the units. So we either measure grams, okay? So that's grams, and that dash means per, okay? That dash means per, so grams per second. So how many grams are formed in a second, or how many grams are formed in a minute, okay? So that tends to refer to mass, okay? So we'd use like a mass balance and we'd work out its weight. So, and we could measure how many grams are formed over a certain amount of seconds, or we look at centimeters cubed, okay, and that's often measuring a volume, okay. So we might say so many centimeters cubed of gas are produced per second or per minute, okay. So it's looking at how much is produced over a certain amount of time. Okay, there are three main ways of measuring rates of reaction: measuring the volume of gas given off, measuring the mass of the reaction, okay, or looking at a colour change. Okay, so they're the three main ways to measure rate: measuring the volume of gas, measuring the loss, or it could be a gain of mass, and then a colour change. Okay, and these are the three things that we use to measure them. So if we're measuring the mass, we'd measure that with a balance. Okay, so sometimes you can use quite fancy equipment and hook it up to a computer. Okay, but other times you can just use just a mass pan balance there and just measure the mass over a time. Okay, this is just recording it so you can see that towards the end less mass is produced. Okay, then we can measure the volume of gas given off, so we can more accurately use a gas syringe, or you could use a measuring cylinder underwater, and you can see that the gas is collecting there, so you can work out how much gas is collected based on how little water is in the measuring cylinder. Okay, using a gas syringe is more accurate though. You get a higher resolution. And then finally, we can do something called inspection, okay? So inspection is just timing how long it takes so you can no longer see the X, okay? Forming, we can sometimes use light and a light sensor, so we can add our solution together and then our light sensor will sense when the light can no longer pass through the solution because it's changed colour, okay? Again, that's looking at more accurate results. So finally is our second review. You should have this sheet in your class notebooks. You should be able to just match it up with the drawing tool. Okay, so we've got to match up our diagrams by here to what equipment. So we're just looking at the diagrams and looking at what equipment we've got, and then we're measuring it up to what it measures. To what, yes, well then we're matching it up to what it measures. Pause the screen and have a go. Okay, so I'm going to start off with this one because I can straight away see that there's a balance in it. Okay, I'm going to then move to that one because I can straight away see it's got an X with a cross on it. This one then's got the light sensor. This one has got the syringe, and then that one up there has got the measuring cylinder. Okay, so what kind of equipment do these? What do these equipment then measure? This one then is measuring the time taken for an X and a cross to disappear. That's a really easy one. Anything with a balance is going to be looking at a decrease in mass. Okay. And then there was another one with a light sensor, so that's also going to be measuring. It's also going to be measuring something to do with light. Okay, so that's light passing through, and then we've got 2 for the volume of gas because there's 2 different ways to collect gas.